Hello and welcome. In this video, I'll demonstrate how to configure a network with multi-area OSPF routing protocol. So I have on a screen a topology that I've built in Packet Tracer, and if you're following along this lab and want to build a similar lab, you can pause this video at this time and make a note of the IP addressing. This is the IP addressing scheme at the top here that I'm using for this network. So far, I've assigned all the IP addresses to the various interfaces on each one of the routers and also each of the PCs. So currently, I'm unable to ping from PC0 to PC1. There's no communication across the network because these routers have not yet been configured with the OSPF routing protocol, and there's no static route to send information to different parts of the network. So my PC will not be able to ping beyond the interface GI00 on router 4, but each router can currently ping its neighbor interface. So to verify that I cannot ping from PC0 to PC1, I'm going to send a ping across the network from PC0, and I'm pinging the IP address of PC1, which is 192.168.20.10. So if I ping this, I'm getting a reply from my gateway address, which is the IP address on GI01 on router 4, and this will be the gateway for all PCs or devices in network 192.168.10.0. I can see here that I'm not getting a reply, and if I check the routing table on this PC, on this router, I can see that there's no route going to network 192.168.20.0. There's no route in the table. So after I finish with this, with configuring OSPF on this topology, all devices should be able to ping each other because routes should exist in all of the routers' routing table for every route on the network. So based on the topology that I have on the screen, I have 3 areas for OSPF. So I have area 0, which is the backbone area. Then on the left side I have area 10. On the right I have area 20. So the first thing is I'm going to configure the two routers, router 1 and router 2, to be in area 0 to form neighbor relationship. So the command for that is router OSPF 1. The 1 is basically representing the database number that is only unique to the router. It doesn't have to be the same number across all of the routers on the network. Each router can have its unique number, but to keep it simple, I'll just use a unique number. I'll just use the same number on all of the databases in the routers. So the command to start the routing process is router OSPF 1, and the next command will be to advertise the network that is between these two routers. So the network that I'll advertise is 10.1.1.0, and it's a /30 network. Now, when you're advertising a network in OSPF, you cannot use the subnet mask. You have to use the inverse of the subnet mask, which is called a wildcard mask. So the command to advertise the network will be network, and the network I want to advertise, which is 10.1.1.0, and the inverse of /30 subnet mask is 0.0.0.3, and now I have to specify which area this network belongs to, and it is area 0 or the backbone area. Now, because I'm on router 1, I have another network that I need to advertise, but this now will be in area 10, and this network is a 10.1.1.8 and a /30 network. It'll be in area 10. So it's network 10.1.1.8, that's my network, and the wildcard mask will be the same as before, 0.0.0.0 3, and now I'm advertising this in area 10 and enter. So with those commands, it will start the OSPF routing protocol on this router, and it will also start sending OSPF packets on the interfaces configured with IP addresses within these network ranges. So over to my router 2, I have to enter the same commands. Router OSPF 1, and I advertise the same network in area 0. Now remember, one condition for OSPF routers to form a neighbor relationship is the interfaces that will be making the connection, it must be in the same network. So if I use any other network, it will not work. So that's one of the conditions before OSPF routers can form a neighbor relationship. And I'm advertising it in area 0, and I should see a message on the screen saying that the OSPF neighborship is formed. Okay, so this tells me here that an adjacency has been formed between these two routers, router 1 and router 2. So I've run the command show IP OSPF neighbor on both of my routers. On router 1, I can see that I have one neighbor, and it is tells me the neighbor ID, the state, and the IP address of the neighbor and which interface this neighbor is reachable. Now if I go over to my router 2 and I run the same command, I can verify that I have a neighbor as well that is pointing to router 1. So back on router 2, there's one other network that I have to advertise, which is this network of 10.114/30, similarly as we did on router 1. So now I'll go ahead and advertise my network of 10.114. And a similar subnet mask that we used before. Well, it's not a subnet mask, it's a wildcard mask, 0.0.0.3. And this time I'll be advertising it in area 20. Now, if I go over to my router 1 and I show my IP route, it'll take a couple of seconds to pick up the new route. Okay, so it took a few seconds for the two routers to converge. So now I can see that I have in my router 1 routing table, I have here an OSPF route, and IA just means intra-area. That is because the route is advertised in another network, or sorry, another area. Over on my router 2, I can see that I have a similar network here. The 10.118 is sitting, it's an intra-area route, it's an OSPF intra-area route because it is sitting in area 10. So the next step in my configuration is to advertise the OSPF networks on router 4 and in router 3. So with these two routers, router 4, I have two interfaces that is connected to two different networks. So gigabit 00 is connected to network 10.118, and it will form a neighbor relationship with router 1. And there's another network on interface gigabit 00, which is 192.168.10.0. So both of these networks will have to be advertised, one with a /30 net mask and one with a /24 net mask. Similarly with router 3, but router 3 GI0 interface is in network 192.168.20.0, and these two routers will only belong to area 10 and area 20 respectively. So I'll go ahead and work on router 4 first. So router OSPF 1. So this starts the routing process, and now I'll have to go ahead and advertise the network between router 1 and router 4, and that is network 10.1.1.8 and 0.0.0.3, because it is the wildcard mask for a /30 subnet, and this area will be area 10. I'm advertising this network in area 10. So I have another network to advertise, which is 192.168.10.0. This here will be a different wildcard mask, so it's the inverse of a /24 mask. As you can see that I have it here, it's a /24. So to advertise this will be 0.0.0.255, and the area will be area 10. So that advertises my two networks, and I come on router 3 to do. So over in router 3, I'll have to advertise the networks in OSPF, and this will be area 20. So I need to advertise two networks, the one network connecting between router 3 and router 2, and the network off of the gigabit 01 interface. And that network will be 192.168.20.0. So that's my network there, and this is my wildcard mask, and the area is 20. So once I do that, I allow a few, about a minute or less for the network to converge. Okay, so what I've done so far is configure the OSPF on all of the routers and advertise the networks in the various areas. So my next step is to check the routers, each of the routers routing table, to see if they have a complete view of the network. So I'm on router 4. I'm starting from this end of the network, and I'm looking at my routing table, and I can see that I have routes to all of the networks, including the 192.168.20 network, which is on the far end where PC1 is connected. And I've checked all my routers, and I can see that I have a similar view of the network on this router as well. I have all my networks here. On router 2 is the same, and if I check on router 3, it will also have the same number of networks in its routing table. So this is router 3, and I can see that I have all of the networks. Now if I go ahead and ping from PC0 to PC1, as I've done here, I can see that I'm getting a reply from that PC. So I hope this video was helpful in helping you to understand how to configure multi-area OSPF. In another video, I will run some OSPF troubleshooting commands, and we will have a look at a little bit more in-depth look at the routing table, at the OSPF database, at the neighbors, the interfaces, and that is coming up in part 2 of this video. Thanks for watching.